Let's solve the fifth problem of Laplace transform, and in this problem we are having a time domain signal xt and xt is equal to e power rt, where rt is the unit ramp signal, and we are required to calculate the bilateral Laplace transform xs and also the region of convergence. So let's see how we can calculate the bilateral Laplace transform and the region of convergence. We know the unit ramp signal can be written as t multiplied to ut, where ut is the unit step signal. So we can write our time domain signal xt equal to e power t multiplied to ut, and we know ut is equal to 0 when t is less than 0. So we will have e power t multiplied to 0, or we can say e power 0, and e power 0 is equal to 1. So when t is less than 0, xt will be 1, and when t is greater than 0, we know ut is equal to 1. Therefore, we will have e power t. So this is how we can define our signal xt. And if you focus on this part of the definition, you will find this implies u minus t, because u minus t is equal to 1 when t is less than 0, and it is equal to 0 when t is greater than 0. And when you focus on this part of the definition, you will find it is equal to e power t multiplied to ut, because ut is equal to 1 when t is greater than 0. So we are having xt equal to u minus t plus e power t multiplied to ut, e power t multiplied to ut, or we can write signal xt is equal to e power 0t multiplied to u minus t. E power 0t is equal to 1, so this will be same as u minus t plus e power t multiplied to ut. Now we will calculate the region of convergence of this signal and the region of convergence of this signal. And once we have the two region of convergences, we will combine them to get the final region of convergence. And to calculate the region of convergence, we will use the shortcut method. So let's calculate the region of convergence of this signal, and according to the shortcut method, we compare sigma with the real part of the coefficient of t in the exponential. So here we are having the real part equal to 0. So we will compare sigma with 0, and we will have sign of less than between sigma and 0, because we are having u minus t here, and we know u minus t is a left-sided signal, and whenever we have left-sided signal, we have less than sign between sigma and the real part of the coefficient of t. So this is our region of convergence for this signal, and following the same process, we will have sigma greater than 1 as the region of convergence of this signal. We are having greater than sign because ut is here, and ut is a right-sided signal. Now we will quickly plot the two region of convergences in our S-plane j omega sigma. We will first plot sigma less than 0. This is the origin, and sigma less than 0 means all the region on the left hand side of the straight line sigma equal to 0. And to plot this region of convergence, we first need to locate sigma equal to 1. Let's say sigma is equal to 1 here. We will draw a line sigma equal to 1 like this, and according to the condition we are having here, sigma should be greater than 1. This means all the region on the right side of the line sigma equal to 1, and you can clearly see that there is no common region of convergence. There is no intersection between the two regions. Therefore, there is no common region of convergence, and as there is no common region of convergence, this implies Laplace transform will not exist. So this is our answer. There is no common region of convergence and the Laplace transform will not exist. So this is all for this question. If you have any doubt, you may ask in the comment section.